everybody, in today's tutorial what we're going to be doing is we're going to be looking through a question in a previous exam from a chemistry exam from 1984, so a long time ago, long before you were born and even before I was born, so chemistry still did exist. Okay, anyway, here we go. Here's the question, and basically what the question is saying is it wants you to find the strongest oxidizing agent and what the EMF, or in other words the voltage, of nickel and tin is when you combine them. So let us interpret this question. Basically at the moment what we find is that we have two galvanic cells set up. Now they're separate, okay? So in this galvanic cell we have lead being the electrode and we have nickel being the other electrode. Note that you have a positive charge for your lead and a negative charge for your nickel. And the difference between the voltages in that particular case becomes 0.1 volts. Okay, then in the next case, you have lead as your electrode, okay, and PT. Now PT stands for platinum. Okay, so it's just, you use platinum or you use carbon when you have solutions as your reaction is in solution state. So you then use things that can still carry electrons, but they are not necessarily reactive at all. They can't be actually. Okay, so here we have a concentration of Sn4+ ions and Sn2+ ions. Okay, so just note that in this particular year they did not provide an electrochemical series, so they expected you to be able to do this by pure understanding of what is going on. Okay, so it says find the strongest oxidizing agent. Now, in order to interpret something like this, the way I generally start off from what the charges are on the actual electrodes. Because this is a positive charge, I immediately know that for electrons, the electrons will actually be moving towards that positive charge. So that will be the way electrons will be moving, okay, that way. Electrons will be moving. Okay, which means that my nickel has to be producing the electrons because they are flowing from nickel down to the positive charge, to lead. Okay, so I'll interpret that in a moment. Okay, and in this particular case, because now the platinum electrode, which contains the tin, is positive, the electrons are flowing that way in this particular scenario. Okay, so what we'll find is we can actually order these in accordance on their electrochemical series, remembering that things that like to accept electrons are found on the top of your electrochemical series, and things that don't like to accept electrons are found at the bottom. So, because lead is accepting the electrons that nickel is producing, that basically means that on your electrochemical series you first have lead and then you have nickel. Because nickel is actually, as you can see from this diagram, electrons are going there, so nickel is producing the electrons. So lead wants more in that particular scenario. So let's just write them in order. And finally, if we look at this particular this particular galvanic cell, in this particular case, the electrons are traveling towards your tin. So tin wants electrons even more than lead wants electrons. So tin is going to be found highest up, okay, on your electrochemical series. So first we have tin, then we have lead, and finally we have nickel. Okay, so that is our order. Now the question says find the strongest oxidizing agent. So what I'm going to do is I'm going to just rewrite these equations in terms of their ions. So I'm just going to remember that I had tin, lead and nickel. So basically I'm just going to write the half equations. So tin is Sn4+, it accepts electrons, it accepts 2 electrons and it creates Sn2+. I'm going to write the same as they have in the electrochemical series. Then we said that it was lead. So lead ion, remember the ions are always on this side, plus 2 electrons, give you lead solid. And finally what you'll find is that you have nickel. So you have nickel ions plus 2 electrons, and you have nickel at the very bottom because nickel does not want to take up electrons out of all of these. Okay, so that is your order of electrochemical series, and because you're finding the strongest oxidizing agent, if you remember to be an oxidizing agent, that is the same as saying the strongest reduction, okay? So I always remember oxidizing agent is undergoing reduction, okay? And therefore, the thing that wants to undergo reduction the most out of all of these equations is the thing that will actually follow the criteria of reduction, which means it accepts electrons. So it's basically this equation here, because that one's the best at accepting electrons out of all of them. And so the oxidizing agent is actually going to be that molecule there that actually accepts your electrons. So it's going to be SN4+. Okay, so now that we've done that, the next question is, what will the EMF of nickel and tin be? So again, you don't know the voltages because the electrochemical series was not provided in this particular year. So what we need to do instead is we kind of have to understand how we get EMFs in the first place. So the way EMFs are calculated is that you generally use this equation. So the overall charge, so this is like overall, equals to, you basically take the voltage of the thing that's higher on your electrochemical series, and you take it away from the voltage that is lower. Okay, that's how I remember it. You can have different values there, you can have, oxidant, reductant, or whatever, but that's how I remember it. And